right, so this is part 2 of the Chapter 5 test. We're starting with problem 8. A copier was purchased for $14,400. For tax purposes, the machine depreciates at $1,600 per year. So this is a key part here. Depreciates at $1,600 per year. And then it's telling me on my next thing here what my variables represent. If X represents the number of years after purchase and the value of the copier, then the value of the copier Y. So we know that we have our X value being the number of years after the purchase, the value of the copier is Y. And then they give us the equation here. Y equals 14,400, which was our y-intercept, that is the value of the copier at the original time of purchase. And then we have our slope at $1,600 per year, and that's decreasing. So it's going to ask us what is our y-intercept and ask us to write it as an ordered pair. For this particular problem, we don't have to do anything. Our value, our y-intercept, when x is 0, when time is 0, when the copier is purchased, the value of it was 14,400. And so what that tells us is that it is C, the original value of the copy machine. What is the x-intercept? So remember that the x-intercept is the value of x when y equals 0. And so I would just take the equation and in place of y, I would put 0 because I'm looking for the x-intercept. It's the value of x when y is 0. And then I would solve this equation. So if I would bring this x over to the other side, it would become positive. And if I would divide both sides by 1,600, I would get that x is 9. Okay, if we think about this, 9, 0, our x value was the amount of years after the purchase, and our y value is the value of the copier. And so if we look at that, it is going to take 9 years for the copier to have 0 value. And if we look at that choice, that would be choice B. And then this last part here has us just take the equation, which was given to us in the original problem. And it wants to know after 6 years. And so X is our number of years. And so we would put in 14,400 minus 1,600 times 6. And when we figure that out, that is going to be 4,800. All right, so looking at problem 8. Problem 8 says determine whether the lines are parallel, perpendicular, or neither. So we're just looking at slopes here. If they are parallel, they have exactly the same slope. If they are perpendicular, the slopes are opposite signs and reciprocal of one another. If they don't fit into any of those categories, then they are neither. Means that they intersect, but they don't intersect at 90 degrees. So if I take this first equation, I really just have to get these into slope-intercept form. So I'm going to take and solve for y. So I'll leave the 8x where it is. I'll bring the positive 1 over. It'll be a negative 1. and then I'm going to divide everything by 7. So I'm going to get that y is equal to 8/7 x minus, excuse me, minus 1/7, excuse me. And then this second equation here, negative 40x plus 35y equals 1. Solving that for slope-intercept form, I'm going to bring the negative 40x over, make it positive 40x. Divide everything by 35. And I'm going to have y equals, when I reduce this 40 over 35, when I divide by 5, that is going to give me 8/7 x plus 1 over 35. Now remember, I'm looking at the slopes. The slope here is 8/7. The slope here is 8/7. So therefore, same slope. These lines are parallel. All right, let's look at number 10. Number 10 says that a bakery uses a large bin of flour for the bread making machines. One day a worker measures the depth of the flour in the bin every 2 minutes. The table shows the data. What is the rate of change of the depth of the flour? Okay, so we're looking at when the level of flour bin falls to 10 centimeters, the machine shut down. If there is 24 centimeters in the bin now, how long will it take for the machines to shut down? So the first thing we need to do is we need to figure out the rate of change here. And so I'm just going to take two ordered pairs, 0 and 86.4, and 2 and 83.2, and I'm going to do the slope with it. So I'm looking for my change in y, 86.4 minus 83.2, over my change in x, 0 minus 2. So when I take 86.4 and I subtract out 83.2, that is going to give me 3.2 divided by negative 2 is going to give me a negative 1.6. Now, I already know the equation of the line here because it gave me the y-intercept. This is the value of y when x equals 0. So this is the y-intercept, my b value. And so my equation of the line would be y equals negative 1.6x plus 86.4. So what it tells us here is that we want to know when the level of the flour, the bin falls to 10 centimeters, the machine shuts down. It's currently at 24.4. How long is it going to be until the machine shuts down? Well, if we look at it at 10 centimeters, so I'm going to remember that this is my x and this is my y. So it's giving me 10 centimeters, which is a y value. And I'm going to put that in place of y, and I'm going to solve this equation for x. All right, so we're subtracting 86.4 from both sides. So we're going to have a negative 1.6x equals, we're going to have to take 10 and subtract 86.4, which is going to give us a negative 76.4. And if we divide both sides then by negative 1.6, then we are going to have 47.75. So what that tells us is that at 47.75 seconds, then this is at 10, depth of 10 centimeters, and the machine will stop. Now we need to continue on and figure out when is that y value 24.4. So we're using the same equation, we're just substituting in for y here. 24 is equal to a negative 1.6x plus 86.4 0.4. And we're going to subtract 86.4 from both sides. And we have 24.4 subtracting 86.4. That is going to give us a negative 62. And then we're going to have to divide both sides by a negative 1.6. And that'll give us that x is equal to 38.75.
Hold on, baby.
And so what that tells us is that 38.75 seconds, we're at 24.4. And so we are looking for the difference between these two numbers that we found for our x values here. And so when I take this 47.5 right here and 47.75, excuse me, and I subtract out the 38.75, that is going to give me 9. And that tells me that the machine has 9 more seconds until it shuts down.